When the downtown lights start to come out at night, we go insane, we go insane. And when I arrive, I start to lose my mind. I go insane, I go insane. Cause they told me you take too much. Yeah, I sure do, so I can feel that now. If they only knew how this was, yeah, they would too, just to feel that now. Cause I ain't got no friends, I ain't got nobody. All I got ahead is a moonlit road. I ain't got nobody. All I got ahead is a moonlit road. When the downtown lights start to come out at night, we go insane, we go insane. And when I arrive, I start to lose my mind. I go insane, I go insane. Cause they told me you, cause they told me you, yeah, they told me you, I can feel that now. Cause they told me you, cause they told me you, yeah, they told me you, I can feel that now. Cause I ain't got no friends, I ain't got nobody. All I got ahead is a moonlit road. Moonlit road.
Shutting us out like you never act like this before. Turning around, I don't wanna lose you anymore. Falling down, no one's gonna save you from your storms. Let it go, you lose this battle. You can't stop me now. You can't stop me now. You can't stop me now. You can't stop me. You can't stop me now. You can't stop me. Me. You can't stop me now. You can't stop me. Me. You can't stop me.
मम्मी टीवी नहीं तो रूम बंद कर दे.
Open your eyes. Step by step, you walking through the door. Turn off the light. can't stop me. You can't stop me. Cinderella boy, I love you. Kimiko yumi ni kiss. Galakimiku, could it be a destiny? Honestly, a mystery. Must be you. Cinderella boy. Cinderella boy, I love you. Kimiko yumi ni kiss. Galakimiku, could it be a destiny? Honestly, a mystery. Must be you. Cinderella, will you be there? Cinderella boy, I love you. Kimiko yumi ni kiss. Galakimiku, could it be a destiny? Honestly, a mystery. Must be you. Got you. Must be you. Cinderella boy, I love you. Cinderella, will you be there? Got you.
Can you see the stars align? A night like this can never rewind. Can you hear the wolf cry out to the light? A night like this will never shine so bright. Couple steps back as you hear me start to hum. Take a couple steps back when I lose all control. Watch me turn into a couple steps back. When I lose all control, watch me turn into a werewolf, and I will hunt till the break of dawn. Don't you dare to try to stop me. This is the heart of the black swan. Let's pray there is more than we know as the countryside clears and the cities full of the world. The world is yours. Let's pray it doesn't bring you to tears as the people awoke and there was unusual fears of the world. The world is yours. I'll stay forever a day to keep you safe as it's so unpredictable. I'll pray that this is the way as the earth falls. You know that the world is yours. Our days are losing their light, and the only safety is to stand up and fight for a world. The world is yours. Our days are darker than stone as the people think that this is their only home. But the world is yours. And I can show you that we can endure the tides. They'll knock us down, but we'll survive. Only with you in my arms tonight. I'll stay forever a day to keep you safe as it's so unpredictable. I'll pray that this is the way as the earth falls. You know that the world is yours. I'll stay forever a day to keep you safe as it's so unpredictable. I'll pray that this is the way as the earth falls. You know that the world is yours. after dark. You'd have been on my mind all night long. Maybe we'd have got a vodka lemonade. We show the cool kids how to be the youth of today. We jump the fence and play in the Mr. Grogan's pool. Hit call the police and we hide behind the school. We spend hours throwing stones into the sea. They were the best days of my life, I promise thee. Oh, I could be a saint while you would be the sinner. My mother used to frown when I'd invite you home for dinner. Oh, my darling, how I miss you to the day I'd give my everything to see your face again. Oh, I'm so sorry I've been distant in the past. I've written tons of letters and they'd ended in the trash. Oh, my darling, how I miss you to the day I'd give my everything to see your face again, oh, my friend.
Hello everyone. Yo, what's up? So I hope how how are you everyone? I'm fine. So yeah, today we will see about introduction to IoT security, and as well as we will see how you can configure your own virtual lab setup for the ARM basically. So yeah, let's jump into the our main content of today. So let's get started. So for basically I am just gonna use a fresh install of Kali. So yeah, everything will work on the commands over shown in the screen will be work on any Linux system, basically all the Debians. Yeah, and steps is nothing but you have to install QEmulator. So everything we will work on today is on the QEmulator. We will see how you can do the installation of a Debian based ARM v7 of the Debian on the QEmulator. We will do network setup as well. So generally the by default network setup in the QEmulator doesn't allows you to have direct access to the ports. So you have to forward the ports, and that's pretty tedious, but there is a way you can set up a network as well. So yeah, let's get started. So yeah. So you must be wondering like where uh, I'm following these steps. So basically like these all steps which we gonna today are available on my blog as well. You can check it out. It's cjhackers.net. Let's open it up. Okay, what's wrong with the Kali? Yeah, is it hanging? Oh, everything is fine. Let's open it from here. Yeah, it's gonna be a bit laggy because I am streaming on my poor old laptop. But I hope the your stream output is good basically. Let me know in the chat if you have any audio related issues or you are not able to see my screen. Let's have a music rolling in the background on the very slow voice.
We fooled around when we got to 22. I remember falling but you ran.
Yeah, so let's continue on. Poor browser is being laggy. Yep. Let's zoom in. So yeah, we will install these set of packages like QEmulator system, lift guest fs tool. So basically this will allow us to work with finalization of our setup. So basically when you do the installation of your uh, QEmulator machine, basically you have to tell your kernel that which specific hard drive partition has your file system. So you have to set those boot parameters basically. So after the installation you just edit out those parameters. For that we will use the lift guest fs tools. We will see further details. Bridge utilities, then these are all DNS masks, these are all for network setup, we will see. And yeah, work manager is like a GUI. If you want to in the future, like you want to use GUI for the Q emulator, work manager is also a good option. But there is a small limitation with work manager, is that it doesn't support 32-bit versions of ARM or MIPS quite well. So yeah, so let's continue on. So first command is for the installation. Basically you have to install all of this software. You just copy it out. Sudo. Oops. Yeah, sudo, because yeah, it's a new Kali. So in the new Kali you have to type sudo every time, since default user is not root anymore, sadly. I have turned off the webcam, so yeah, you have the good stream output, no lags. My face is not needed that much, I guess, because you just want to follow the steps. Guys, don't forget to subscribe to my channel, because now I'm thinking to commit to the YouTube finally. So yeah, I will try to do streams on the monthly or the weekly basis basically. And yeah, you will see a lot of IoT security related content as well. There are a lot of plans I have. Finally, like it took me an outbreak to finally commit to a YouTube. Basically, I always wanted to do, but yeah, since lack of time, I didn't. But luckily, opportunity came up, and I finally decided that I should do it and share my knowledge with the rest of the world. Basically, so please subscribe if you haven't subscribed yet. Go ahead, click that red button, smash it. Or if you have a 0 days to increase subscriber count on the YouTube, please go ahead and use that as well. This default car mirror is slow. Let me change it, I guess. It's pain. Sorry, I forgot to do this before the stream. I usually use this one from Czech Republic. It's good one. Yeah. Now let's cancel this up and again do it. It should pick up good speed. Yeah, look at this. Look at this speed. I don't know why it's like that. Maybe the lot of people uses default Kali mirror, and yeah, might be a bandwidth limitation on their primary server. So if you switch to the other mirrors, your speeds gradually increases because not many people are using those mirrors. Most people are just on the default one basically. But Now you can see it's from the 20 minutes, now we are down to just 1 or 2 minutes over here basically. Yeah, so whenever you face this issue of slow downloads in the Kali, you can just go to the mirrors list, official mirrors list over here, this one, and you can change it to the whatever is the nearest one to your country. It lists according to the nearest one to your current country basically. So yeah, I generally use the first one from the Czech Republic. Feel free to ask me questions in between if you have any, like how to get started into IoT security, what was my experience, how did I got my job. You can ask me all sorts of questions while this installation stuff is going on. Let's meanwhile download our other files as well in the background. So now we are doing installation for ARM. My blog actually also have, it's almost same steps. If you, okay, how did I start? There is a question from a Rahul in the chat. So yeah, basically I got first interested into firmware reverse engineering basically. So into first what I did was while I was learning stuff about OHCP and all kind of stuff, actually I got interested in, I saw a video on the firmware modification on the YouTube basically. So from there how to hack NASA, which, bro, that's not a possible, you already know that. Unless you have a 0 days in their NASA satellite, you can do that. You can, uplink your HTML payload to the NASA satellite and let them download it from their satellites. So yeah, let's continue the main question asked by the Rahul. So basically, I first learned about how to modify a firmware binary on my Cisco Linksys router. So yeah, what I did was I created a small MSF Venom backdoor and then put it inside the firmware binary. So basically, I used the firmware modification toolkit. There is a tool for that. You can modify pretty much any router firmware. So I modified my router firmware and put the MSF Venom backdoor inside it, and I had found a shell script for rotating logs inside my router. So basically what happens is routers usually have the administration panel, right? When you visit 192.168.1.1, you will have this administration panel of your router. So it runs the web server, right? So that web server generates some kind of logs. So my router had this a script running, shell script running at a startup. So what was it was doing was it was rotating logs on the certain period of time basically. So I put my uh, basically linked paths to the backdoor. It's like forward slash bin forward slash name of the binary. So yeah, I put the backdoor, my backdoor path to the backdoor inside that shell script which was executing periodically, and I just uploaded that modified firmware to my router. So you may ask, what was the actual vulnerability? So basically my router was not checking whether firmware is assigned by the authentic developer or not. It was just pretty much accepting any firmware given to it, which is not a good security practice, right? You should always check for the signatures, and your router should know what is the public key which has signed that particular firmware. Not a public key, sorry, private key. And router should know the public key to verify that signature. So signature verification was missing. That's why my router was accepting any modified firmware, and basically I was able to root my router. So that's how I got started into IoT security, by learning this firmware modification attack. And yeah, that's how I got my first job as well. Like, I also, during the NullCon, my current employer Secure Layer 7, they had hosted a hardware CTF. I tried that hardware CTF. My team, I had my university, I have a security team in my university as well, which is known as Sector 443. So like with my team, we had tried that CTF. They liked my profile and I got the job. And yeah, that's how I get into started into IoT security. So I basically started from firmware reverse engineering. So I hope all this answers your question, all answers your queries, Rahul. Next, move to the next question. Like, Neil is asking, do you have any knowledge about kernel modification? Nope. I don't know much about like kernel exploitation in depth, but I know how to develop a basic rootkit, and how you can, inject a malicious kernel module, create your own basic kernel module which can give you the reverse shell. There is a book called Linux Device Drivers. You can search it on online. It's a free and open source book. You can read about it. Linux Device Drivers. Basically, it goes through how to develop a Linux kernel module. So you can use that knowledge to create rootkits. And there is also a course on the Pentester Academy by Vivek Ramachandran. So Vivek Ramachandran teaches you about the Linux kernel rootkits for Red Blue Team. So that's the name of the exact course. If you have a subscription of Pentester Academy, just check that out course on Linux rootkits. So yeah, that's how you can go through the kernel module stuff, and you can have an introduction about kernel space basically. Hey, what's up, Anurag? We are seeing today how to do setup for ARM reverse engineering. So we just finished installing all our software. So QEmulator should be there, and yeah, QEmulator system ARM, it should be there. Now it's installed. So now we have to create a empty hard drive. Oh, first we need to download two things. First is a kernel. You have to download our basically kernel for our operating system, and yeah, initial RAM FS. So basically, what is initial RAM FS? It's a file system which gets loaded into RAM during the installation, because obviously just alone kernel cannot do anything. Basically you need a file system. So this file system will not store anything on your hard drive. It will be just like stay inside the RAM, and once the installation is complete, nothing is saved basically. So after during installation, it stays inside the RAM. Once the installation finishes, all the data are transferred to our hard drive, like all installed files and everything will be on our hard drive, and we need to modify our boot parameters to load into that, launch into that file system, and tell our kernel where is our hard drive partition located, where is our kernel located, basically after us, where is our file system located. That stuff we will see. So this is the link. Basically if you go to this site, which is http.us.debian, yeah, till here. Shiraz, today I will cover how to set up a lab for ARM reverse engineering. Shiraz, you can ask me the questions about. It's all about introduction to IoT security, basically. Nothing much advanced today. We will just see the overview of everything, and we will go through the setup. So you can see all the files listed inside this Debian server. So we need actually installer for ARMHF. ARMHF is nothing but ARM version 7. So it's just a similar CPU to your Raspberry Pi 2, I can say. Raspberry Pi 2 is ARMHF as well. It's ARM version 7. I don't know idea about Raspberry Pi 4 since I don't own one, but it may be ARM version 8, which is 64-bit. So ARM up to ARM version 7, it's 32-bit. ARM version 8 is a 64-bit, and your Android also is a ARM version 8. It's a 64-bit. Yeah, your smartphone runs on 64-bit of ARM basically. So if you click on installer ARMHF, go to the current images, then the netboot, you will see initrd.gz and vmlinux. These two files we want to download. So let's copy and download. So like if you want older version, you can just, instead of Buster, you can choose any other one. Let's download this. Okay, this one is a bit slow. Yeah, it will catch up the speed. Yep, two things are downloaded. Now let's continue further. So first we will create an empty hard drive of 20 gigs. Let's just I'm not sure whether I have 20 gigs right now. but it won't occupy 20 gigs from the start. But let's I guess from virtual machine 4 gigs is enough for now, but you can set it to any size you want basically. Right now I'm just selecting 4 gigs. So yeah, it's created. If you type fdisk, then the name of the file which you just given. Oops, I guess I don't have right now. No problems, but it should be created anyways. It's there. Yeah, it says accumulator hard drive image. Now let's boot into our system. So we will use this set of options. I will explain what are these. So first we will tell we are using which CPU we are gonna use. We are gonna use Word CPU. Word stands for nothing but virtual basically. And yeah, it's booting up. As you can see, installer is booting. So M for RAM, we are setting 2 gigs of RAM. SMP stands for number of CPU cores, which are 2. I am saying kernel is this file, and the init RAM fs this file. These two we just downloaded from the previous commands. These are the some other hard drive formatting stuff. We are telling what kind of hard drive is that. So we are saying it's a what IO block device. So this is the type of virtual hard drive basically. Now we are booting into our installation. I guess I should decrease the RAM, it's pretty bit slow. Yeah, keep the questions coming. Oh, it's horribly slow. Let's open in the GUI mode basically. You can open it to GUI mode like this. Let me just open the new one. Just remove this no graphic option. You will be boot into GUI mode. So that window will be provided by your work manager basically. Yeah, and switch to the serial mode. Yeah, let's reduce some RAM. We don't have much right now on the virtual machine. 512 is enough. One core is enough. Now everything should smooth out. So yeah, basically there are two ways you can do it totally in command line. If you don't have installed Word Manager, and if you have installed a Word Manager from by following my steps, you would be able to have this window as well. It's pretty good and more stable. Yeah, bear with me, it's pretty slow, but yeah, it's at least going on good so far without crashing. No, no output. What is going on? Give me something. Should I seriously increase my RAM? Or like, let me close the browser. That may help. So yeah, obviously you will need working internet for this entire setup, which I forgot to mention. Because most of the files it will download from the internet. It will go online and download all the missing files and upgrades. So it's detecting for network card, which we already defined in this command. It's this one, netdev. This is actually our NIC, virtual NIC. Yeah, you can ask questions as well. Or you can catch up with the steps if you are watching this stream live and trying to do it on your computer. Just open up my blog and you can catch up with me. Oops, localhost is fine. Yes, Nirav, it's a QEmulator virtual machine in which it's a fully emulated environment basically. Yeah, like you will be able to cross compile stuff as well. So meanwhile this stuff goes on, why not we look into the ARM instruction sets basically. Let's do that. I will tell you the basics of ARM instruction sets. My blog is like my notes basically, so if I forgot something I can tell you accurately. At the end of the stream I will tell you how you can learn all this stuff which I learned over time. So yeah, this is ARM comparison. Oh nice, Nirav. Nice, so you did it with okay. So you did it with the actual hardware. That's good. If you have a heck lot of money, obviously you can buy a lot of testing hardware for IoT security. But if you are a broke guy like me, you can obviously go with reverse engineering stuff. It's up to the researcher's choice basically where they want to pursue, whether they want to pursue into more of the hardware related stuff or they can just stick to the software reverse engineering part in embedded software. I'm sticking to embedded software reverse engineering part because yeah, as I said, I'm broke and I don't have enough money to buy the hardware as of now basically. So yeah, this is the basic comparison table over here. As you can see, there are general purpose registers, there are special purpose ones which has specific use. So R0 to R5 register in ARM is the general purpose register. So it's like in x86, if you know reverse engineering and the basics of assembly in x86, it's relatively to your EAX, EBX, ECX, EDX, ESI and EDI registers. So in the ARM, those registers are denoted as R0 to R5. And this R0 to R5 holds the your function arguments basically. Like let's say if you have in the C program, if you have a function like this, for example, let's say you have func A and you have like two arguments, int x comma int y. So value of this int x and int y will be held into R0 to R1 register basically. So yeah, R0 to R5 holds your, uh, R0 often also holds the value of function call. Uh, and R6 to R10 in this R7 is your syscall. Syscall is basically like it's like you are invoking system related command. So this syscall are invoked from the user space, and you're basically there will be layers of security inside your any processor. In ARM it's pretty much three. In Intel, like there will be ring 0, 1, 2, 3, 4 likewise. Oh, that will be nice. If you can put the link or something, Nirav, that would be really good. Or you can tweet it out. I will retweet your post. Just tag me on the Twitter. So yeah, so R7 will hold your syscall number. So basically, like you wanna create a file or you wanna open a socket inside your Linux OS. So R7 will hold that syscall number. R11 is your basically EBP in x86 or its frame pointer. These are special purpose. Rest of the like R12 is intra procedure call. R13 is your stack pointer or ESP, you can say. It's denotes the your top of the stack, and yeah, it's LR link register. So LR is like it holds in the ARM. There is a one difference. Like in x86, you usually, with the help of your return, basically once you do the return, your EIP will the hold the return. It will have the return address. So likewise, LR holds that value in ARM. PC is your program counter or EIP, and EF flags is nothing but your CSPR. So these are the details about your ELF structure in your any Linux binary. Let's check where we have reached. Oh, installation is still going on. So yeah, usually like these are the section located in any ELF. Like let's say ls. So you can do this, read ELF hyphen h and like let's say ls. So ls is our basically ls command, and you can also denote the section as well. So these are the sections located under ls. So a lot many sections are there. But likewise, there will be these common sections inside any ELF binary. First one will be like .txt, data, plt, and got. So you may ask why you need to know these all sections. Basically, in the binary exploitation, you should be aware about usage of each and every one. Text is your basically all your instruction sets are there. When you disassemble a binary, actually your disassembler goes to the .text section and read the instruction sets over there, decode those instruction sets from hex and show it to you. Basically the logic will be inside that disassembler itself. So yeah, you may ask what are the good disassembler. My personal favorite is Radare 2. I love it. It is it's just like a Ghidra as well. Like what Radar 2 can do, Ghidra can do as well, and what Ghidra can do, Radar 2 can do as well. But one thing I like about Radar 2 is you can automate it a lot with scripting. It has great support for Python. Ghidra has a support for the Python, but it's a JPython, and JPython runs on Python 2, and as we all know, Python 2 is pretty much dead. So for that reason, for the developing plugins inside the Ghidra for a newcomer, it's pretty hard, because you have to, if you are not good at the Java stuff, yeah, it will, you have to go through a lot of documentation of Ghidra to develop a plugin. But in Radar 2, it's so easy to do that. You can automate a lot of tasks, you can do analysis, you can create your own plugins for Radar 2 very easily inside the any programming languages. It has thing called Radar 2 API, and that Radar 2 API is supported in the Python, Go, Java, and lot many other programming languages. Where in Ghidra you are only limited to JPython for plugin development. So this is the basic shell code of your fork bomb. As you know what is fork bomb. Fork bomb is nothing but you create a lot of infinite number of threads, so your CPU will run out of the resources, and yeah, it's like crashing your PC by opening a lot of processes basically. So you can one question, like how you can check the syscalls, basically how you can get the syscall number. So like you can do this man. So there is a one thing about manual is that you can do man2, so it's like man2 for syscalls and 4. So yeah, if you want to read manual about syscalls, you type in man2 and then name of the syscall. There is also syscall open, this is to open a file. There is also write. There are a lot many useful syscalls, networking related as well as bind, socket, all kind of stuff. So this is the this is the text section. As I said, text section holds your assembly, and global, here we can define set of variables we want to, variables or the like other sections. This is your actually global GOT, it's your global offset table. So in the global offset table we are saying we will have this section called underscore start, from here we will start the execution and all kind of stuff. So yeah, we are switching from 32-bit to 16. In the ARM architecture there is a called thumb mode. In the thumb mode you can basically like switch between the 32-bit and the 64. It's a backward compatibility feature, like in older versions of ARM they used to run on thumb instruction sets. So you and the one advantage of using thumb instruction in your shell code is like you reduce number of null bytes basically. Like if you, it's a like even in the x86 and 64-bit, if you use a 64-bit shell code, it will have a lot of null bytes due to, you know, its size, address space size, and how much it's a length of the instruction. So by reducing the, you know, bits, you are actually reducing null bytes over here as well in your instruction sets, which gets decoded by your CPU. So we are changing to 32 to 16 basically. And instead of telling add R70, we are doing EOR R7. So why we are doing this? Because if we directly assign 0 to R7, so that 0 will be included in our shell code and it will be denoted as a null byte. So reduce one more null byte, we can directly null out the value like this without actually having the null or a 0. So if you XOR something with a something which is empty, which is again 0, then we are doing the syscall. So basically we first said push 0 to R7 and then push 2 to R7, and as we talked, R7 is our syscall. So it's a syscall for your fork, basically creating a new process. Then we say execute that once, and then after that syscall is executed. SVC stands for supervisor call. So basically, as I said, there are multiple layers when you execute a syscalls. It depends on the security provided by your CPU architecture. Basically, as I said, in Intel there are like ring 0, 1, 2, 3, 4. In the ARM it's only 3. One is user space, one is a supervisor, and third one is your kernel space. So basically supervisor will translate your requested syscall to the kernel one, and it will return the output from the kernel space and give it back to the user space. So that's how a user space program can safely do the syscalls to the kernel with the help of your supervisor. There is also alternative to this. You can use SWI, software interrupt. That's also there. And yeah, this is one like doing knob. If you do move arret in ARM, for knob instruction you have to do like this. In x86 you directly use knob, but in ARM you just do it move arret, or there is one more method as well. Still going on. And yeah, this one is telling branch link. Branch link is nothing but jump. It's relevant to jump, so it's telling go to the loop. So it will again execute all of this. It will again null out the R7 register. It will again execute syscall number 2, which is your fork. So it will, in infinite loop, it will again and again create new process, and eventually your CPU will run out the resources and it will crash. So basically in ARM you can check out this syscall numbers. It's mentioned in this file. It's called unistd common.h. This is the whole path. So this is for system ARM v7 system, which we are setting up over here. Yeah, and there is also YouTube demo as well. And these are the resources I was talking about. The Billy Alice, this guy has very nice YouTube channel about iOS related hacking stuff. He is also good at kernel stuff as well. He also recently posted video how to random your own characters in iOS device with the help of kernel hacking. Do subscribe to his YouTube channel. Azaria has very nice vlogs on ARM. Yeah, this one. See, the very first video is about iOS kernel fuzzing. This guy is really talented. And Azaria Labs is all about ARM. She has also a nice blog how to get start into ARM stuff, how you can learn all. She has step by step blogs about how you can learn the entire thing. It's a really nice blog. I learn it like I continuously read that blog for at least a week or so, followed all the steps. Now I'm pretty much confident about ARM assembly. At least I can write my own shell code, which is null byte free. So yeah, shout out to these two amazing InfoSec people, Billy Ellis and Azaria. I guess this will take more around 20 minutes or so, but it should not take this much long. It will like around 40 minutes or 30 minutes of process depending on your RAM and resources. Right now I'm streaming as well, so it will take around 20 minutes. Yeah, go ahead, keep asking your questions if you have. But I'm at least streaming today till 9 p.m. So what we will see further, like what happens when this is done. So yeah, blah blah blah, set up this, that. Yeah, once your installation is finished, you have to pass this boot parameters basically, and like we will edit the contents of our hard drive. We will copy out our installed kernel from hard drive to local directory, and our all other stuff which is needed to basically boot our system. Initramfs, installed initramfs and installed kernel, that we will copy out to our local directory and use this to boot inside our actual installed OS basically. And we will also append a kernel argument which is root dev vda2. So this tells the vda2 is nothing but a hard drive partition. So our root file system will be located at vda2. Yeah, root is for root file system. So you are telling your kernel where to look for the root fs basically. And after that we will see this script, QEmulator script for networking setup. This script will let you have a NAT network which you can use for directly interact with your network services inside your QEmulator virtual machine. So it makes life easy. You don't have to forward a port every time. You can just directly work with SSH and all. And it will look like the end result will be like this, something like this. Yeah, you will be able to see it's a ARM based QEmulator machine. Okay. Oh, we are back. Now it's asking for a root password. Like, let's set it as a tour. Easy peasy. Again, tour. Let's call it as CJ Hackers. Password is password. There is a slight input related issue whenever I press down button from my keyboard. Actually, it goes back into the main menu inside the installer. Yeah, until this is not setup is not done, your keyboard layout is pretty much fucked up. So yeah, you will pretty much sometimes end up choosing default ones. But solution is that to use the command line mode. If you want a nice looking output, you go with the GUI. But if you want stable keyboard input, you should go with command line mode with no graphic option. I guess probably we are almost done with the setup. Like it had downloaded files from the internet. Yeah, when it comes to these things, you have to be got a lot of patience. And now I guess it's hard drive setup, like hard drive partitioning. So yeah, there is a big mistake you can do easily over here, which is using LVM, local volume, logical volume management, setting up logical volume management. Don't do that because you know, when you come to this setup, you come to this part of setting up your boot parameter. If you use logical volume group, you will not know which exact physical partition your physical partition is situated for the, you know, your root file system. So it will be create a lot of issues. So please don't use LVM while doing partition setup. Oh, if you just have joined the stream or if you are watching from the start, don't forget to hit the like button. Yeah, it helps too. I want this video to reach as many as people possible, so more and more people can learn all this stuff and start doing IoT security. So yeah, hit the like button, smash the subscribe button if you are just joined or watching from the start. Don't forget that. Sorry, I was away for a water break. Yeah, so as I said, don't select encrypted or LVM, just use guided entire disk one. And yeah, it should detect your virtual hard drive, which we created as 4 gigs. So yeah, select all files in one partition because we want the predicted partition table. We know like VDA1 will have your bootloader, VDA2 will have your file system. So yeah, Now over here you just do the finish partitioning and write changes to disk.
Let me in or let me go. Honestly, try honesty. No, just tell me what I want to hear, 'cause it could save us. Let me fly, I've got my hopes, but I can hardly see why I'm still chasing. It's not worth it for me anymore. Crashed and burned 100 times, I'm lost. I just can't let this go. Every last chance I had is gone, but I just can't let you know. But I just can't let you know.
I hope all you guys at home are safe. Health is good. Yeah, it's pretty much hard times, but if you see it as a hard time as a good opportunity, it's like good learning opportunity as well. Like you have a lot of time, you can learn new skills. So yeah, everyone stay safe in this current outbreak. We all know what is it. I don't need to name it. Few more steps. If you want to take a break, you can take a break. Hello guys, so we are gonna end the stream soon. Like if you have any final questions, you can go ahead and ask. I will put out the entire installation video in separately because this is taking a lot of time, to be honest, and it will just keep on going on. If you have any further questions, go ahead and ask. So yeah, if you it seems no one has any further questions. We are gonna end this stream. Thanks for watching. I will put out the entire installation video on my channel. So if you haven't subscribed yet, you can go ahead subscribe, so you will get the notification as soon as I put out the entire installation video. I didn't thought that it will take this much amount of time. Yeah, but it's taking too much time. And yeah, even it's my all the steps are there on my blog cjhackers.net, and don't forget to follow me on Twitter as well. So yeah,